Welcome, everyone. Thank you for joining us for today's webinar. My name is Odette Hines, and I'll be your moderator for the webinar entitled Introduction to Sony's Presence, Low Power Consumption. Your presenters today will be Armagon Ibriami, who is a partner solutions engineer at Sony. She worked with different divisions at Sony to bring the innovations to developers and businesses to build scalable solutions. She has over 20 years' experience in the high-tech industry with a mixed background on hardware and software engineering. She has worked on chip-level verification on ASIC and FPGA all the way to video player on Android and iOS devices. She supports Sony's presence in North America. Our other presenter is Kamil Tomaszewski, is a developer programmer at Sony. He's one of the major contributors to the Spresense technical support. He has supported CircuitPython on Spresense. He is currently supporting Spresense documentation, building demos and tutorials, as well as interacting with customers and developers on the forum and events with technical questions. Now, without further ado, I'd like to turn it over to our first presenter, Armagon.
Hi, everybody. This is Armagon. Sony Spresense is a development kit, and we are using we are targeting IoT application, which they need edge computing with low power consumption. In this webinar is more like intro, so I'm going over some of the details about Spresense and how to start with Spresense, and hopefully you will get good information out of this webinar. Let me first tell you what is covered in this webinar. I will give you some information about hardware, software tools for Spresense, and then I will talk about target applications. After that, I'm going to talk about secret of low power, and then I will talk about multi-programming using Arduino IDE, which is one of the popular features that we have provided for Spresense. So first, let's talk about what is Spresense and what do you expect, what do you get with Spresense. Spresense is a development kit, is a compact development kit, and as you see in this slide, I have divided to two sections. So if you look at the right section, it's going to give you all the features and highlighted capabilities of Spresense. And then the table on the left, it shows some more detail as far as the spec for Spresense. Spresense has 6 ARM cores. So I'm talking about the right side now. Spresense has 6 ARM cores, and it has six ARM cores using FDSOI technology to make it ultra low power. So I'm going to give you a little bit more information when we get to the section for low power. And also we are using the ASMP framework for the multiprocessing. It means that for each processor, you have a dedicated memory. Again, in the section that I talk about low power, I elaborate more and tell you how this works and how it helps with the low power capability. The other capability that we have for Spresense is high resolution audio. We are Sony, so one of the price that we have is our audio systems and audio capabilities. Why not give that access to our developers to have high resolution audio? So high resolution audio is one of the capabilities of Sony Spresense board. And also we are supporting GNSS, Global Navigation Satellite System, in any place in the world, in Russia, in China, in US, in Japan. And so you can program and you can use this capability. Most of the boards out there, they don't have GPS. So this is one of the highlighted capability of Spresense. So now that you know what are the features, let's look at a little bit more detail about the spec for Spresense. Spresense, as I mentioned, it has 6 ARM cores. This ARM cores, the type is M4F, which has a clock frequency of 156 megahertz. The SRAM is 1.5 megabyte. We have also a flash memory, 8 megabyte. You can have access to digital I/O, which are GPIO, SPI, I2C, UART, and PWM. And then for analog inputs, we have 6 channels, 3.3 volts range. And of course, we have high resolution audio. For audio, we have 8 channel for digital mic, 4 channel for analog mics, and we have stereo speakers. As far as GNSS, as I mentioned, so we have GPS in the US, GLONASS in Russia, BeiDou in China, Galileo in Europe, and QZSS in Japan. Other type of other options or other aspect that I would like to share with you is we have a camera interface on the board. So you just slide it in and you connect your camera, and then you have a SD card access. You can put your files over there, maybe for AI, maybe your music or anything that you need to get access to. And then also I scored as capability. So you got now this page is one of my pages to show to people to in one glance you will see all the features, a little bit of a spec. So now let's talk about the board configuration. With the Spresense kit, what you get, I'm starting from the left side, you get a camera board. This is a very simple camera to just make prototyping faster. And then we have the main board, and then we have the extension board. Main board, as you can guess from the name, this is the brain of this development kit. The rest, the camera and extension board, is just to make your life easier. So for the next slide, let's talk about what is in the main board, what is it supporting, and so on. So for the main board, as you see in this picture, I have 2 chips. On the right side is CXT5602. This is the brain, and then CXT5247 is another chip that we have on this main board. These 2 chips are Sony chips, has already been used in a smart headphone from Xperia headphone from Sony. So this has been already used in an actual product. And if you want to understand the chips a little bit better, so look at under each of these, I have listed the functionalities and supporting capabilities under each of them. Let's look at the CXT5602 on the right side first. So we have low power GNSS function. This is the GPS or Galileo or other capabilities that you need for global navigation satellite system. We have multi-core processor capability on this one, and then high resolution audio codec, and then also the camera interface supporting by this chip. And then let's look at the left side. The other chip, which is CXT5247, is taking care of the power management, Class D full digital amplifier, microphone interface, a speaker interface, and battery charger. So this, if you look at this, you can build on top of this board to make your prototype. But at the end, when you go to mass production, you get these 2 chips. So you can design based on the information that I give you today. It's basically how you can use this development board to do your prototyping. But eventually, if you go large volume, then you get these 2 chips to build your actual product. So let's see what are other, because I show you other components. So basically, if you look at this slide, you will see on the top right, you see the extension board, and then you see the camera board next to it. And I have 2 more pictures, which is showing BLE and sensors. Why did I put these things together? Because Spresense is low power. You can do edge computing. You target IoT applications. For IoT applications, what you need is, of course, the extension board gives you more capability, access to audio out and others that I'm going to talk about more. And then you have camera, but you need to connect this to a bunch of sensor. You need to connect the Spresense board to a bunch of sensor to get some information from your environment. Maybe this is a field that you need to get temperature. You need to get some information from your sensor, so you can add your sensor. Also, you need to have some type of connectivity. It can be Bluetooth, Wi-Fi, or any type of connectivity that you need. So when you put these things together, you can build your prototype. Extension board that you see here is just to make your life easier. What does it do? You have access to a SD card, which, for example, one of the demos that we did, we built the whole model for our AI, and just we put it on that SD card, and then Spresense board could access that information to do some recognition. I'm going to talk about it a little bit more later. But also, you can put with the extension board, you can add Arduino Shield on this board because it has the Arduino form factor. And so basically, extension board is to make your life easier. If you just need the main board to build, that would be enough. Then you don't need, if you don't need to access to this capabilities on the extension board, don't worry about it. And then camera, again, we have this slide. You can start to put the camera. It has the camera interface. You can connect your camera, again, to make your prototyping faster. Okay, so let's talk about this a little bit more and tell you how you build your prototype. We are making this a lot easy, flexible, expandable, and we are using the sandwich concept design. So sandwich concept design, it means that in the middle you see my main board. I'm telling you, main board has the chips, is the brain. But the others on top, they are all of other connectivity or your sensors or anything that you need to add, and you put it on top of main board. And then if you look at the bottom, I have LTE board, I have extension board, and also I have a portable player extension board as well. What does it mean? It means that, okay, I have my main board. If I need to connect to LTE, I can connect it in the bottom to the LTE. Or if I wanted to access to any Wi-Fi or BLE or LoRa or any type of things that to give me the connectivity, I put it on top of the main board. So one thing that I would like to mention here is LTE board is actually a new product that is going to come out in the summer. So it has been already very popular in Japan, but we are trying to bring it as soon as possible to US as well, and North America, and to provide it and provide it to our developers and customers. So here you learn how this is the sandwich concept. Let's go to the next slide. And here what I would like to explain is, I told you the top part was all of the connectivities. So for the connectivities, it could be a function add-on. So function add-on, it could be a Wi-Fi or BLE or any type of connectivity. And sensor add-on that you see on the left side is any type of sensor that you need to get temperature, you need to get the moist or any kind of information regarding your sensor. Then this is how you build your prototype. You put it on top of main board. So as you see in all of these pictures, it is very easy to do prototyping. We are trying to make it faster. One thing that I would like to mention about the previous slide, actually, let me go back. So as you see here, main board is from Sony, extension board is from Sony, camera, of course, is from Sony, and then LTE board is from Sony. The other connectivities or sensors that you see here, even the portable player extension board, these are from our third-party partners that they are providing that. But what I would like to say is you are not limited to this. You can go with any type of add-ons that you want. So, and then this one I explained already. So far you have learned about the board, you learn about the spec. Now let's see how we can program this board. To do any development with this board, you can use two things: Arduino IDE or Natex SDK. Arduino IDE, why? Because it's popular. There are a lot of developers. They use Arduino to develop their prototype, and Natex is more for advanced user. If you are more comfortable with command line, just go with Natex. The other thing that I would like to mention here is Natex, it gives you more flexibility. If you want to change a library, if you want to make it custom, you can do it on the Natex side. So, and the reason that I'm saying this because of the next slide, but I'm going to tell you later. So here I have provided two videos. One of them is in the bottom, if you see the sign. So is the starting with the Spresense SDK for Arduino and sorry for the Natex, and also I have the Arduino video. I'm not going to play these videos. I'm trying to put all of the information and supporting materials and links that you need to look at in this slides, that later on when we share this with you, you have references and you know where to start. So make sure you go to these videos. After 6 minutes, next thing you know, you can just set up your whole system. You can light up the LEDs that are already on the board and know how to, your first Hello World program is gonna start with these two videos that I have provided here. So one is for Arduino, the other one is for SDK Natix. So we learn about the hardware, we learn about the programming. Another thing that I would like to is very exciting to share with you is Spresense is an open source hardware and software. So you can build your own add-on, you can build your own extension board, and all of the information that you need to start with is in this link that I'm providing here. So you go there, you look at the files, you look at the schematics and all of the information that you need to start with. So we are sharing this. We have a very good document online, and we have a forum to support that. So make sure you go and look at that, and if you have any question, you can submit your question to our forum. Last thing about Spresense and what is Spresense I would like to share with you is artificial intelligence. Usually when we have any IoT application, we need to make it smart. We need to do some development to make it even more capable. So to bring that capability to Spresense, right now we are offering this free tool, which is Sony Neural Network Console. You don't need to be a data scientist to use this. If you are an engineer, you want to do development, you can use this tool easily, and you can build your network, neural network, your model, and then you can feed it to Spresense. And also, let me tell you this, in my next webinar, I'm going to give you more details, more training, and tell you exactly how you can use this tool, and maybe give you a detailed example also, step by step, how you can do it. But it's very simple. It's very easy to use. It's all GUI based, and we just made the data sciences very, very easy to use this tool. Use this tool, sorry. So let's see what is happening here. So when you build your IoT, you need to collect data. This data can be images that you need to take a picture of a cat, like you need to take like 6,000 pictures, right? So to take that picture, if you look at my Spresense here, is already connected to the camera. Camera can take that picture for you. So you take all of your pictures. Now you have your database or data set ready. And then when you have your data set, you have to go to tool that is NNC or Neural Network Console. The link is in pink. I put it up there. And then using that tool, you can design your neural network. You can train the neural network. You can produce the trained data. So all of this is happening in this tool. And then after that, you have an NNB file. That NNB file is your whole model to detect the cat face or detect the gesture or detect something that I'm talking about image here. So you have that, or you have that ready. Then you need to install the network and the trained data on Spresense. So the next step is you get that output, you put it on Spresense. And then again, when you want to do recognition, you use the camera from the Spresense and you do the recognition. I have provided, if you look at the left corner, I have provided the DNN runtime library for both Arduino and Natix SDK. So if you want to go through step by step and learn and see what it is, please use this link. Also, in my next slide, I'm going to give you another exciting thing. So this is an example. I think it's very simple and is just give you the idea of what you can do with Spresense. This is a simple example. The game rock, paper, scissors. I think most of us are familiar with this. If not, it means that, so rock is, so you're showing gesture with your hand of a rock or a scissor or a paper. And what we are doing here is we are building that database. Means I'm taking a lot of pictures from the different gesture of my hand for rock and scissor and paper. When I build that database, I need to take it to NNC, Neural Network Console from Sony, and then I build my network, I bring it to Spresense. So what is the expectation? I need to detect the gesture of my hand. So if you show, we use the Spresense camera. So if it shows the scissor, it's gonna, on a little LCD, it shows you this is a scissor. Or if it's rock, it shows this is a rock. The important thing here is this is a very simple example. But what I want to tell you is this demo is only using 3 out of 6 ARM cores. And just with using 3 cores, is the execution time is only 0.07 seconds. So this is really fast. That's why we say Spresense is good for edge computing. If you need a device to be constantly connected to the cloud and communicate with the cloud, don't go for Spresense. Spresense is good for edge computing, means it's sitting somewhere, it's detecting some data, and then when it needs to get connected, then it's gonna get connected to the cloud. This is a very simple example. I have also provided the video here for you, so make sure you go and watch it, and then it's very simple, it's a very short video. So let's see what happened. I told you everything about hardware, software, what tools to use if you want to do AI. So now you have an understanding, a little bit of like of everything, that what Spresense is. Now let's see what can we build with this Spresense. What are the target applications? In this section, I have divided this to 4 different groups. One is, the first one that I'm going to talk about is Industry 4.0 applications. Why Industry 4.0? Because we have a lot of factories, a lot of machineries that they are old. We cannot replace them. We cannot just shut down a factory and say, oh, we're going to replace everything. Not only the production line is going to be delayed, but also you will not have the budget. It's going to be very expensive. What if we can monitor this factory and make it a little bit more smarter? So let's see what Spresense can bring to this Industry 4.0. Spresense has high resolution audio. So it's not just for music. You can detect sounds. You can just detect the abnormal sounds from your machinery. The machine is working, and then you can detect the sound, and then from that you can compare, you can build your database, and then if any abnormality happening, then you can detect it, you can prevent it, you can maintain it. So then your production line is not going to be delayed. So still, we can use Spresense to make our factory smart. This is one way. The other way is using image processing. Image processing, again, it can look at your machinery, and if it sees anything abnormal. For example, here I'm showing the smoke is coming out. So hopefully it doesn't happen in your factory, but again, if it happens, you have this device to detect it and then send an alert. Hey, come to this place, and this I'm seeing some abnormalities, right? This is something wrong. Or one of the very, very, very popular applications that we see in so many factories is the meter reading. Meter reading, we have a lot of analog meters in our factories. So all the data, someone walks around, collects that data and share it with people that they are responsible or they need to take an action. But what if we can make it smarter? What if we can make it more efficient? You can use the camera low power. Actually, this is using the image sensors and connected to the Spresense, and then look at the meter. And then when you look at the meter, basically you can detect and then get that information, and then you can do even some processing. Like this meter is right on the correct number, or this is going over, the temperature is so high, I need to take an action, and send a notification to people that they need to take an action. So these are just very simple examples. I'm sure people that they are working in factories, they have so many other issues that they can use Spresense to address them. I'm here providing a link to wear indication for bearing using edge computing. This is actually using the high resolution audio to detect the abnormality in the factory. So this is just mimicking that idea and using FFT, Fourier transfer, and all of those things to detect that. This is another link that I'm providing for you. Make sure that you go there and take a look. The other application, so we're done with industry. Let's go to another application. So of course, agriculture, our environment, these are very important to us because our life depends on it. It's one of the sources for us to survive is how our agriculture and environment is doing, right? So for Spresense is we have worked with researchers, and also we have worked on some applications targeting issues in the to address some of the issues that we get in our farm. So I'm talking about the picture with the cows on the left side. So so you see cows like roaming around, grazing and enjoying their life probably on the field, and then we have done some projects to detect the animals where they are located. Of course, we have GPS capability, and also monitor the health of our animals and see if they need to be attended, or if there is something wrong, we can take care of it. So, and also there are so many other applications that we can use to monitor our animals. Maybe they are grazing in one specific location, and then that location, we find out why. Maybe then we can, if we need to switch the place, or many other details that a farmer can take care of it and make it more efficient for them. They can use Spresense for it. And also, I'm talking about the picture below that is about soil data collection. We are working with agriculture companies, and they're building drones using Spresense with one of the state-of-the-art image sensors from Sony. And what's happening, they are giving the farmers different type of crops, and they want to see in a year or 3 months how they are doing. And then this drone is going all over the field, collecting the information and share that information with farmers. Not only that, with the agriculture companies to see how they can improve their products. Also, insurance companies, they need this information as well, because they wanted to see how this field is doing, and then as far as supporting and all of this thing, they can get that information, and they find it very useful. So let's look at the other picture on the right side. So the top one, I'm talking about the crop monitoring. The crop monitoring, we have done a very exciting project with IBM Watson, and basically, if you click on this video, you can see the demo. What we have built is just a little garden that you need to take care of the temperature, light, and the health of your plants. So you can detect all of that information and sense all of that using Spresense. And then when you have that information, if you need to do any communication with the cloud, you do the communication with the cloud, and then you send the alert or notification. You can even make it, add voice command to it, or many other things. But basically, just to mimic that idea that how you can monitor your crops, this is another example. Another exciting project that we did was with enthusiastic developers from all over the world, and one of them is from Argentina. We are concerned about our wildlife. We don't want it to get harmed from there are a lot of people that they harm our environment or wildlife. So the project was basically monitoring the wildcats, that they are going they are just instinct, because of all these people, they are trying to make money out of it. So they are monitoring the cats, and for this kind of application, you need something that is sitting in the middle of nowhere, that it doesn't have access to power, and also you need to do edge computing, because if some illegal activities happens, if you hear, for example, a sound of a gun or something like that, then you need to detect it and send an alert. And then you need to use the low power and edge computing capabilities for this kind of application, because we are not living in the forest, right? So it's so far away from our habitat, but we need to get that information to go and rescue these animals, to go and help, and to go and use this technology to save our wildlife. At the same time, what I would like to say is about our forests. There are a lot of people that they are trying to do illegal activities like logging and illegal logging, which we can use Spresense again for audio, for example, or GPS or other capabilities, that it will detect the saw is working and someone is cutting these trees, and then you can send a notification. So a lot of so many applications that we can cover in this section. But let's go to the next one, and I'm talking about the third one, which is infrastructures, smart cities, applications that is around us in the place that we are living in. So there are applications that you can use as Spresense for surveillance camera. Against cameras, you may need to collect some information, images, and Spresense has 6 cores, so you can do a lot of image processing. We can use fisheye lens camera to with Spresense, to pair it up with Spresense to do some of this application for surveillance camera. Also, we need to monitor our rivers because of the chemical. Again, these are something that constantly you need to check. If you see something that is not matching with your spec, then you need to send an alert like this: the chemical is too high, or there's something new in this water and we are drinking this water, or something like that. Also, is good if you want to use for traffic, road monitoring. Again, this is camera. As you see, camera. These are all image sensors. And because, again, Spresense has 6 cores, can handle this. For the parking monitor camera, this is a very interesting application. We have built a demo for this. I have provided the link that you can go and check it out. So you want to go to work, you're going shopping, you're doing you're just in the city and you want to find a parking. What if you can access to different locations and see which one it has availability before you go to a parking structure and go all the way around and find the right place for you to park. So it's going to save you time, save you money, less gas, and all of those things. Again, it makes our life smarter. Then we can use our time better, and also we don't waste money or waste money. So the last application that I'm going to talk about here is the power transmission towers. Any type of tower. This is specifically is for the transmission towers that usually these towers are sometimes it's not in our city, but we need to constantly monitor this. I don't know. I live in California. So many of you may have seen the wildfires happening in your area, and some of them it just started from this power transmission towers, or so constantly you need to monitor this. Also, we have other projects that we are working on to, for example, monitor a water tank that is for the city to give water to the whole city. You need to check the level. You need to see if the pump is working, or if there's any extra, like some chemicals in the water. So you need to do monitoring, and these towers are very tall. People are climbing up all the way up to collect this data. But the Spresense is low power. It can do edge computing. It can sit there and watch it 24 hours. So why not? This is about the infrastructures for the city. The last one that I want to talk about is medical application. The examples that I have provided here is more toward low power and high resolution audio capability. The examples are electronic stethoscope, hearing aids, and portable ultrasonics. So what you see in all of this, they are not plugged in the wall 24 hours. You need to have the low power capability. And also for the you need to do some, like for the ultrasonic, you're doing a lot of image processing. What does it mean? I need processor, I need powerful processors to do that, and I need edge computing. So these are some of the applications that I would like to share with you for the medical. Hopefully we can use Spresense to address some of the issues that right now we have with this coronavirus. But so this is just some applications that I share with you. So I'm going to the next section, which is the low power. So what is the secret of low power? So let's see what we have done so far. We went over all of the details as far as hardware, software development, and programming things that you can do with Spresense. And then after that, I just told you about all the applications, but you're telling me, okay, this is IoT, you're saying low power, how, why? So let's go a little bit into details and see how Spresense is bringing this capability. When we say low power, what does it mean? How we are maintaining this in Spresense. So the first slide is just looking at the transistor level. So transistor, don't get scared. This is just a very high level overview. I make it very simple, then you understand. In the transistor level, we have here, first of all, what I'm doing here, I'm comparing the bulk CMOS and FD-SOI. This is nothing but two different technologies. When we build our chip, when we build our silicon, we are using these two. So, but we have the choice. You can go with the bulk, you can go with the FD-SOI. So far so good. Let's move on. Now, what is happening here at the silicon level? When you go all the way down in your chip, this is what you see. You have a gate, you have source, you have drain. What does it mean? It's just a switch. Gate is a switch. And if it basically means you are turning on and off a light, this is how you transfer the power in your chip. Okay. So see what's happening. If you look at the bulk CMOS, I have the gate, I have the source, and I have the drain. The current is going from the source all the way to the drain. On the top picture, you see some arrows are bending. What does that mean? It means, oh, I have leakage here. Leakage means what? The power, yeah, I'm losing power here. So now look at the yellow box. The power that you're using for a bulk CMOS is 1.1 volt, okay? And I'm using the same ARM cores. I told you we have 6 ARM cores. So I'm using the same ARM core, but 2 different technologies, right? Now let's see what Spresense has. Spresense is using FD-SOI. What is FD-SOI? Is a big word, but look at the explanation on the right side. Is fully depleted SOI layer. What does it mean? What does it mean? So it means I have the gate, I have the source, I have the drain. The current is going from the source to drain. But do you see those bending arrows here? No. Why? Because I have a silicon on insulator. What does it mean? Means I put an insulator there, then I'm avoiding those leakage. If I avoid that leakage, what does it mean? Means I am using less power. So now let's go back to the yellow box, and here you see only 0.7 volt. So compare 1.1, 0.7. So I think now you know why when we say Spresense is low power and we are using FD-SOI, what does it mean? This is at the transistor level. So we talk about this. Next, let's look at the block diagram. So that is like a little bit, it's very much deep down inside. And now let's look at our block diagram. What is happening here is you see red, yellow, green, and blue blocks. Each of these has, we have divided this CXT5602, which was the brain, which was what I had on the main board. And I told you is, so that one is basically, I'm showing you in high level what are the blocks, and each of these block is responsible for something. The red block, what is it called? Application domain. The application domain, what is doing is processing block for you. So it's process block for user application. What is the yellow one? Yellow one is system and IOP domain. So this block is managing all of input, output, and power for you. And then I have a green block, which is the sensor domain. You are controlling all of the sensor that it comes to your board in this block. And then at the end, GNSS domain. GNSS is Global Navigation Satellite System. So it's your GPS, is your GLONASS, is all the navigation system that you have on your board. So the reason that I put this here, and let's see how with this the different blocks I can save power. Look at the green block here. I'm going to start from there. Why? Because when you have your IoT application, you connect to so many sensors. I talk about applications like in the farm. So you need to get the temperature, you need to get the light, you need to see if the plant is healthy or not. All of those sensors comes to the chip and goes to this green one, right? When it goes to this green one, what I'm telling you now is, okay, if you need to take any action, then you go. So this offers, first of all, when it comes to this block, means this block is awake and it comes out of idle, right? But if you need to communicate, if you need to get any IO power, then you go to the red one. And if you need to do any processing, then you go to the red block. Or what does it mean is Basically, all of this block at the beginning are in sleep mode. They are idle. They are not on. They are not using any power. But as you progress and as your application needs to access this block, it wakes them up. So that's how we are saving power. So this is at the block level to just give you an overview. Another good way to explain this maybe is if I show you the power transmission, how the transition, how it's happening from one stage to another stage, and I'm highlighting the amount of power that I'm using. So ignore the middle blocks. Just look at the two yellow ones on the side, and then on the top corner, I am just highlighting the different blocks that we have in this in the block level, right? The green and yellow and all of those that I talk about. So here you have in the yellow one on the right side, you get all of your inputs. This input can be a motion sensor, it could be a microphone, it could be an analog sensor. So for example, you're getting some information from any of these sensors. When it comes first to the stage one, it means that the sensor control unit needs to take care of this information. What does it mean? If I need to stay here, so a motion has been detected, do I need to stay here or do I need to get IO? If I need to stay here, don't take any action. At this level, stage one, you are using only 100 microwatt. So this is the amount of power that you're using here. But then if you need to access the IO, you need to go to stage two, the yellow one, which is gonna increase the power. So at this point, it's 500 now. And then eventually, when you go to the last stage, which is a stage three, means you have already, so what happens at this point? So I have the motion, I sense the motion and I detect it. Now I have to do some moving or not moving. If I need to do moving, then I need to go to the stage three, which is at the end is gonna send some output, right? Like it could be audio control, camera control, AI control, or GPS control. And at this point, you look at the number of power that I'm using. So this is another way to explain the previous slide. I'm gonna go through the now you're familiar with this block as the green, yellow, and red and blue. And I'm going to give you a little bit more information about each of those to get a better understanding of how we are maintaining this low power. So first one is the red block. Red block, it was application domain. This is all the processing. This was the last one, last stage, stage three, right? So here is basically this specific block is doing the multicore control and low power consumption. Everything is from here. What is happening? Look at the bubbles that are made on these pictures. The top one, it says CPU cores in no use, turn off automatically. So I told you we use ASMP. ASMP means for each processor, you have a dedicated memory. Again, if you're using the processor is turn on. And if at the same time, if you are accessing that tile, that memory for that specific processor, then you wake that up too. Otherwise, it's gonna be turned off. So at this level, what you need to know is I am doing application domain, my processor is here, but if I'm not using the processor, is off. If I'm not using that memory dedicated to that processor, is off. So this is all about this one. Let's go to, so this was my stage three red. And then now let's go back to the yellow one, which was the middle or stage two. At this point, I'm doing a lot of system IO and power management. Again, this is supporting multiple power modes and to see how multiple power modes. When I say multiple power modes, so we have power off, or we have deep sleep, we have cold sleep, hot sleep. So what we did here, basically, we provided this feature, means you can play with these different modes to save power. So I have, if you see on the right side, I have a table. It may not show all of the details. I will provide the slides, then you can see better. But these are this is nothing but how you can play with different power modes that we have To understand that better, I am providing a link here. What is it doing? This is actually a very good example. You can build your prototype, and then basically you can use a dime-sized battery and connect it to a dime-sized battery, and then you don't need to worry about it for 6 months. So this is how you can manage the different power modes for Spresense to provide that capability. So the last one, not last one, actually I have one more. So this is about the sensor. This is the green one, the one that is first of all, before everybody else is waking up, because it gets all of the sensor data. Here is, we are getting a bunch of data from our sensor. So is controlling all of those. How it controls it, first of all, what I would like to say, you can get this data from I2C or SPI or ADC, any of this. And then you have a sensor engine. In this sensor engine, you are doing sequencer and FIR filter. And then the output of that is either you need to take an action, means event has been detected, so you send a message to DMA controller, or you need to stay idle, so that goes in your FIFO. It's gonna stay there. So this is how we are saving power. So if you don't need to take any action, it's gonna stay in FIFO, right? But if you need to take an action, then the event is detected and you go to the DMA. Last one, finally, for this section, for low power, is the GNSS. This GNSS, what I would like to tell you, first of all, is supporting GPS in the US, GLONASS in Russia, Galileo in Europe, and then by in China, and QZSS in Japan. So if you're anywhere in this world and you want to use the GPS, you have no limitation. And also it's super low power. And on top of that, it has a dedicated core for just this GNSS. We have 6 cores, plus this one, we have 7 cores. But one core is just dedicated to this GNSS. This is one of another state-of-the-art products from Sony that we are using in other things. And we brought that in this development board as well. So last thing for the low power, let's do some comparison. Now you have learned deep down inside what is happening in the block level, what is happening in the transistor level. Let's move on and see some examples that you may be more familiar with, like Raspberry Pi or Arduino, and see how we are doing comparing Spresense with those two. Again, this is just to give you information. It doesn't mean we are better, they are better. It depends on your application. So look at the power consumption. The power consumption for Spresense is the column in the middle. So the power consumption for Spresense is 30 milliwatt, 30 milliwatt with 6 cores. And then if you compare it to Raspberry Pi is 500 milliwatt. And by the way, this when I say power consumption means there is no load. And then for the Raspberry Pi, I put a star 2 up there. So it's Wi-Fi and Bluetooth are off, right? So compare the power. So if your application needs very low power, maybe Spresense is your choice, is a good choice for your application. Also Arduino Nano, again, these are examples. These are very popular. These are good products out there that we see a lot of developers are using. So we are just giving you some information, then you can make the comparison and see where you're standing with the Spresense. And then if you look at the calculation power, so for the Raspberry Pi is 1250 DMIPS. And then for Spresense is 1170 DMIPS. Then Arduino is 20 DMIPS. So this for the calculation power. If you have more, means you are better, you're doing a better job. But Raspberry Pi has an ARM11, only 1 core. We have 6 cores, and then with the 30 milliwatt power, I think this is just to give you the information. Like, okay, I get enough power here. And then as far as board size, it's important because we are building prototypes. We want to know how big our prototype is getting. So it's very much comparable. So it's right in the middle between Arduino and Raspberry Pi. And let's look at other features that they are providing. Arduino doesn't have but if you compare Spresense with Raspberry Pi, GNSS, the GPS available that we have integrated in the board is not available in Raspberry Pi. But both we have audio, but we have high resolution audio, of course. So this is if you need to detect those noise in your machine or other examples that I gave you. So maybe this is a better choice. But again, and then camera interface, both it has it on top of that. Raspberry Pi has Wi-Fi and Bluetooth, and we provide add-ons that then it makes it more flexible. You can go with Wi-Fi, Bluetooth, LoRa, or anything that you want. But again, it depends on you, it depends on application, depends on what you want to do with what are you trying to achieve. So this section, it was all about low power, one of the features. And now this is another thing that I would like to talk about. This is multi-core programming is powerful because we know a lot of people using Arduino IDE. But what we did, we made it easy to do multi-core programming with Arduino IDE. Here is just a quick overview of what's happening. We have 6 ARM cores, but keep that in mind. There is always one core being the main core, and then I have 5 subcores that I can use. So main core is in blue, and subcores is in yellow. And let's see what is the memory allocation for this course. We have 1.5 megabytes, so we divided by 12 tiles, 12 blocks. I told you each core can have a dedicated memory, so we divided it up to 2 sections, the blue and yellow. Blue was what? It was my main core, and then the yellow was subcore. We dedicated 6 tiles to main core. Why? Because you are doing audio codec there, you need memory, so that's half of it, and the rest it goes to your subcore. So you can dedicate 2 of these tiles, you can dedicate 3 of these tiles to your specific subcores, or you can just have 1 memory tile dedicated to the subcore. If you want to look at a good example to start with, I have provided a link here. So this is Multicore tutorial. Please go to our website and check this out. At this point, I think I covered everything. So hopefully now you know more about the Spresense. You know what are the specs, why it has 6 cores, why is it low power, how you can do multi-core programming with Arduino IDE, and where is it standing compared to other products. And then if you want to do, at the end, what I would like to say is if you want to do any edge computing with low power, Spresense is a very good choice to use. So I think this is the last thing that I want to talk about, and thank you so much for joining this webinar.